Okay, Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 11 and we will present to all of you about data mining, which is the thyroid disease dataset. Okay, so this is our group members. So we have data analyst, project leader, senior programmer, database admin, and data scientist. So we will discuss about introduction, a problem statement, objective dataset description, methodology, model building, result analysis, case study, conclusion, and reference.
Hello, my name is Bong Yi Fat. I'm gonna to talk about the introduction of this project. The main goal of this project is to evaluate the performance accuracy of various algorithms for classification tasks. We're using the support vector machine SVM, logistic regression, and random forest are to employ the patient are having thyroid disease or not. For regression tasks, linear regression is applied to model the relationship between a dependence variable and one or more independence variables. The first problem statement is the common endocrine disorder like hypothyroidism and hyperthyroidism can lead to significant health issue if not diagnosed and treated properly. The second is a diagnosis is challenging due to the variety of symptoms and need for comprehensive medical evaluation. The last is a project aims to address the challenge of early and accuracy detection of thyroid disease using the data mining techniques. Objectives. The first is to utilize existing thyroid disease data to form a classification, clustering, and regression models and use the model to assign appropriate class label to the datasets. The second is to calculate probability for predict outcome to understand the likelihood of the thyroid disease. The last is assist in early detection to facilitate timely treatment from medical specialists. The first problem statement is the common endocrine disorder like hypothyroidism and hyperthyroidism can lead to significant health issue if not diagnosed and treated properly. The second is a diagnosis is challenging due to the variety of symptoms and need for comprehensive medical evaluation. The last is a project aims to address the challenge of early and accuracy detection of thyroid disease using the data mining techniques.
Alright, next is methodology. The thyroid dataset can be leveraged using various machine learning techniques to provide valuable insight and prediction. On this project, we use three methods. The first one is classification methods, such as random forest, logistic regression, and SVM. The second one is regression techniques, including linear regression. And the last one is clustering and supervised learning techniques, use algorithm like k-means. Alright, next, the technique chosen for the thyroid dataset is classification because the dataset is a supervised learning dataset. There are three techniques in classification. The first one is random forest, SVM, and logistic regression. Alright, next is regression. Regression technique can be applied to the thyroid dataset to predict continuous outcomes. This involves using algorithms like linear regression. Alright, the last one is clustering. Clustering is unsupervised learning technique can be useful in working with the thyroid datasets. It's group data points based on similarities among features using algorithms like k-means. Alright, next we talk about model development like data exploration, processing, model building, evaluation, and visualization. There are 9 steps in data import and exploration. The first one is file, data info, data table, correlation, box plot, feature statistic, distribution, mosaic display, and the last one is rank. Alright, next is data preprocessing. We have edit domain, outlier, preprocess, and preprocess we have data sample, data table clustering, and content-wise. Data sample, we have a data table classification, and continuous we go to data table regression and select columns.
Okay, so to make model building classification, we should have data preprocessing, model training, data import and initial analysis, data splitting, and model evaluation. Okay, so the next to make model building regression, we should have data pre-processing, model training and evaluation, data import and initialized analysis, and data selection and preparation. Alright. Okay, the third one is model building clustering. So we should have a data pre-processing, visualization and evaluation, data import and initial analysis, and then the clustering. Alright.
Now we will see result and analysis for classification.
Okay, we go to test and score, which is the summary is the best performance is random forest. So because of what? Because superior in all metric, flawless AUC. And then we have do comparison among random forest, SVM, logistic regression, and the result is random forest is most effective, and then SVM good but higher error rate, and the last one is logistic regression, which is the better than SVM, not as good as random forest, right? Alright. Okay, so I will show to all of you about ROC analysis. So we have true and false. The summary of true is the top performance is random forest, and why? Because the best balance of true positive and false positive rate. Alright. So the other is logistic regression and SVM are capable, but less optimal. And then we go to the false, which is the summary is top performance is random forest also, and then because of what? Because most accurate in prediction absence of thyroid disease, right? So thank you.
Alright, so sekarang we will see the confusion matrix for result analysis classification. So we have three models. First one is random forest. So random forest model outperform the others, demonstrating superior accuracy and fewer misclassification, false and true instance. And the second one is logistic regression, shows strong accuracy, especially for true instance, but had slightly higher false negative and false negative rates. And the last one is SVM model. The SVM model performed well in predicting true instance but exhibited low accuracy for false instance, which higher rates or false positive and negative. Alright, now so prediction. The purpose is understand each model's performance, decision-making, process strengths, and weakness to enhance predictive TSH levels accurately. Inside has model misclassification for performance assessment and error analysis, facilitates understanding factor influencing model decision and overall effectiveness. Next, we will see result and analysis for clustering. So now we will see the scatter plot. Cluster analysis. Cluster 1 predominantly no thyroid disorder. Cluster 2 miss of all classes, wide T3 range. Cluster 3 mostly no disorders, same hypothyroidism, higher T3. Regression line, hypothyroidism rate, weak positive correlation. Hypothyroidism low, moderate positive correlation. And negative class green, moderate positive correlation. Interpretation, generally, the three increase correlation with higher T4 levels. Strengths of correlation varies across different thyroid disorder classes. So the next one is seal hot plot. So we have three cluster, blue for cluster 1, red for cluster 2, and green for cluster 3. The cluster 1 score mostly around 0, points not well separated from other cluster, indicating potential overlap or ambiguous classification. For cluster 2, wide range of seal hot score, including many negative, miss of well cluster and ambiguously classified points predicted potential misclassification. And for the last one is cluster 3, seal hot score close to 0, poor separation from other cluster suggesting boundary permissivity. So the last one we will see result analysis for regression. So the first one is test and score. Inside MSE and RMSE, very low values indicating close prediction to actual value with small errors. MAE, minimal average absolute difference between predicted and actual values, confirming model accuracy. R squared, high value suggests excellent fit explaining of variance in target variable. And the last one is MAPE, extremely high value suggests potential formatting or calculation error requiring attention. So the overall impression, strong performance of linear regression model with accurate prediction and good fit, except from the anomaly in MAPE. So now we will see the scatter plot. For visualization overview, hyperthyroidism classes blue, primarily located at higher TT4 and FT1 values. Hypothyroidism cases red indicate lower TT4 level associated with hyperthyroidism, and negative cases green, widely distributed but mostly within mid to higher TT4 and FT1 range. So regression line, hypothyroidism red, moderate to strong positive correlation, hyperthyroidism blue, moderate positive correlation, and negative classes, moderate positive correlation. Overall, effective visualization of relationship and distribution within dataset, highlighting association between thyroid disorder classes, sex, age, and T4 and FT1 levels.
Now I will present about the case study, which is thyroid disease. The article performance analysis of machine learning algorithm for thyroid disease examine how machine learning technique can improve the accuracy of thyroid disease diagnosis. For methodology, this article come out with two methodology, which is feature selection technique and machine learning algorithm. For feature selection, it use L1 based feature selection, and for machine learning algorithm, it use 5 type of algorithm, which is k-nearest neighbor, naive bias, support vector machine, decision tree, and logistic regression. For the tool, this article use skitlearn, which is skitlearn is an open source machine learning library for Python and provide a wide range of tools for machine learning tasks. This article also have to deal with a few challenges. First, data quality and quantity, availability of a limited amount of labeled data for training. Second, feature selection, high dimensional data can lead to overfitting. And for last one, clinical adoption, ensuring that healthcare provider trust and understand the diagnostic recommendation. For conclusion, this project can help for enhanced predictive accuracy at early detection, create tailored treatment plan, and reduce misdiagnosis, and also drive innovation in diagnosis tool and treatment, improve patient outcome, and advance medical research in thyroid disease management.